Why do we need software to help us predict the location of future wildfire alerts? As temperatures continue to rise and drought conditions in the American West continue to worsen, we are going to need to be smarter in managing the resources we have to combat wildfires and to catch them as soon after ignition as possible to lower the suppression costs and maximize the safety of people and structures. This figure here shows the increase in burn areas in the American West based on increasing temperature and the degree of temperature increase due to climate change. Frequency and intensity of fires continues to rise with government funding lagging behind. You can see in the figure here as costs of fires increase due to the increased intensity and frequency of fires, government funding is lagging behind to fight these fires. Currently, in the western United States, national forests share resources with states depending on where the fires are located. However, the western U.S. is very large, and it might take agencies several days to transport people and equipment from one fire to the next. If we were able to predict where large fires might start based on temperature, precipitation, and other weather factors, including lightning strikes and humidity, we can then better plan and optimize resource location to cut down the time between when the fire starts and when we begin to actually fight the fire. Here's a prototype of the code to help us predict where future fires might start based on risk. For simplicity, I have only included precipitation and temperature data and have compared current conditions to average conditions to determine the relative risk. Once I upload the forest data and coordinates and weather data, then I can compare the climate data to determine the relative risk. I use this risk category to determine the current conditions compared to the average conditions. And finally, I import the data to a map here and create a map to create a spatial representation of the data. And I'm going to assign colors of markers to the different risk categories. Here's what the spatial representation of the data would look like, with this region being a higher risk area and this region being a lower risk area. This would enable us to store resources and minimize transportation time if we knew full regions were more susceptible to large fires. And before policymakers and government decision makers would utilize this program, in the future, I would like to develop a method for a user to import new regions based on coordinates and compare with existing. And I would also like to develop a web-based application to download the data in real time and use a dynamic map where you can zoom and interact with the data to optimize decisions to combat these